So, great. So most of you are users or liars, right? What? No? Why do I say liars? Because you're using models every... Not so sorry. I need to see faces. I used to work for fisheries, and I need to see the eyes in my crowd. Why do I say liars? It's because all of you use models every day. You use mental models to think about how the world works. When I came down here from Brainerd this morning, I used a mental model that's based on how to get through your traffic patterns. Right here, I plug in my software, and I zip in and out of traffic using my mental model. So you're all model users. We'll just call some of you liars. So, I'm Paul Radomski. I'm a fisheries biologist, lake ecologist. I haven't used Fortran. This is a statement. I haven't used Fortran since the 70s. I was surprised it was still around, but okay. I do a lot of modeling. I do fisheries models. I used to model the number of walleyes in the lac. Got out of that 10 years ago. Thanks, Dave. When the governor's talking about fish management, you know it's a good thing that you're not involved with it. Right now I do a lot of statistical models, mostly in R. So that's my background. Chris Carlson is the other person that's working on this, and she's a wildlife biologist, a good writer, a decision support staff is that. So she's really helpful in just supporting my decisions or telling me where I went wrong. So I'm going to talk about zonation. And zonation is shorthand for a process. And I'll get into that process, what it is, why we do it, etc. It's unlike anything you've heard for the last 2 days. So be prepared. So we're required to have this slide. Yes. So you've seen this circle thing. Now you're probably sick of it. You are here in the box of developing plans. Zonation is a process that helps you develop a plan. The graphic of the state shows you where we've worked, and we've been evolving as we've gone, but we're currently involved with the North Fork of the Crow, which I'm going to use as my example for this presentation there in blue. It has multiple users. It is designed for everybody. It could be within the department, within the DNR. It could be at a county level. Our users tend to be a mixed crowd. They're going to be the county commissioner. It's going to be the SWCB staff. They're going to be DNR wildlife or fisheries, area hydros. It's a mixed group. And another thing related to the questions that we're supposed to address, I think it's endorsed by the DNR TCA and biologists, although there's probably deniable plausibility in there somewhere. So the goal of zonation in this process is how do we, in a systematic and objective way, prioritize areas on the landscape for conservation. That's the goal. That's the objective, right? Every model has an objective. This is its objective. And the DNR's self-interest in this is you're getting a lot of information. There's a lot of information available to local units of government as they develop any water plan, a watershed plan, a local county water plan, a one watershed, one plan, a RAPS, right? And the selfish interest in the department is how do you integrate a lot of data to come up with a meaningful plan that addresses a key element that we must address within the state of Minnesota is that our conservation problems are larger than the amount of money that we have. Can you invest in areas such that you get multiple benefits for each conservation dollar? This is our self-interest as we bring this to it. So that's why we got involved. I'm going to back up. Can I back up? I need very small thumbs for this particular thing. So I'm going to talk about the North Fork of the Crow as my example, as I mentioned earlier. It goes from Rogers to Litchfield all the way to Green Lake. Green Lake over here at Spicer and in the headwaters. Just keep that in mind because I'm going to speak to that specifically later. So zonation is the shorthand, but it is a process. The processes you normally see in planning exercises, and I've been involved a lot within the department, is what? A bunch of people sitting at a table and talking about things. It used to be called BOGSTAT, an acronym, right? Every model has an acronym. The problem with that approach is the people that talk the most may not know the most. I've been at a lot of meetings like that. You all have, right? So how do you go about developing a plan in a structured way so that you're being objective? And this is one process that we've been using to help do that. So the first step, you formulate what your objective is. What are you trying to accomplish with this plan? And this is the most important part. Aristotle said, well begun is half done. In our process, if you do this first step well, you're good for the most part. So what we ask people, as you've brought a group of people around a table to develop a plan, is what conservation features do you value in this geographic area? And we're talking watersheds most of the time. What are the things you value, and what are the things you want to focus in on? That's the big step. We're asking people about their values. And how do you want those to aggregate? What is your objective? Are you looking for multiple benefits for your conservation dollar? Are you looking to find the best of the best to save those? Be very specific. Be mathematical in that and define what your objective is. So that's step one. Step two is set the weights on each of those conservation features that you said you value. We say that it should be based and reflect the social valuation. It should reflect the group. And we use the analytic hierarchical process to do that. It's a simple decision-making tool. Our third step is run the model. And the model is Zonation. It's a free software out of the University of Helsinki. It's got great documentation, 300-page documentation, detailed. It is one of the two most common conservation planning softwares used around the world. They'll do it at state, at provincial, at country scales. The other, of course, conservation planning tool is MarkScan, which also the department uses for identifying places that we want to invest in for scientific and natural areas. So third step is really simple. It's simple for our users, our group of people that we're working for, because all we do is put in the data and punch the key and it goes, right? And it generates draft priority areas, which I'll show you some examples. And then the fourth step, which is very critical, is what we call a synthesis step. That is, you edit, you finalize your priority maps and areas. I should back up. The output of zonation is strictly priorities. It's ranking every piece of land from one to whatever on a ranking system. That's the four steps. And I'll walk you through each of those four steps with the example with the North Fork Crow. So we usually, as we're meeting and discussing with a group of people, what do they value, what do they want to focus on, we help them and structure that in a hierarchical process. We'll have some buckets, and we usually base them loosely on the DNR healthy watershed stuff. You got water chemistry, hydrology, geomorphology, connectivity, and habitat. So we'll help them think about that. Their first step is to think about the big buckets that they're going to put all the stuff in with regard to this process. So in this case, this is the North Fork of the Crow. Their broad scale categories represented buckets listed here. So improving protect waters of concern, reduce erosion and runoff, and address altered hydrology. Of course, this is the North Fork, a high amount of agricultural use, and they're very keen on improving water quality by addressing runoff issues. Enhancing fish and wildlife habitat was also a thing that they wanted to do. Protect and restore shoreland and riparian areas was critical to them as well. But probably most important, implementing BMPs on ag land was a bucket they really wanted to focus in on. And then protect and improve other lands of concern. Now, within these buckets, then, what were the inputs? So zonation inputs. So you can do as many inputs as you want, right? What do you value? So we usually give them a draft list, but they'll come to the table with their own things that they value. And I'm just showing you some examples. I think in this case we had 28 different conservation features or areas that they wanted to focus in on. So here's some examples. In the upper row, you've got those that go into the bucket for protecting and improving waters of concern. So you've got such things as drinking water vulnerability, which is a plan in itself from protecting wellhead areas for municipal drinking areas. So you can have a plan, be a model input into this model. You've got the groundwater contamination susceptibility, you've got lakes with declining water quality from PCA, you've got HSPF modeling output as an input into this model. And then you can see some other ones that they valued. Rare habitat, some land use, land capability classes that they wanted to focus in on some of their agricultural areas, soil erosion risk, U.S. Fish and Wildlife Service priority wetlands, another model as an input in this process. So a whole range of things that they, as they're sitting around the table discussing about what goes into the model, this is up to them. They're generating the inputs. We're using the inputs then to take. And this usually takes a while. Again, well begun is half done. They're spending time thinking about the inputs to their model. They're building the model as they go. The second step is setting the weights to each of those features. Not everything that we just listed would everybody agree that one should be higher than the other, right? So we need a process by which to objectively set the weights to those inputs that are going to be used in the model. And we say that it should reflect the values of the people in the room that are writing up the plan. Now, hopefully they represent the interest across a jurisdiction, whether it's a watershed or whatnot. So we hope that's the case. We use the analytic hierarchy process, which is just a scientific approach to making group decisions. So what it simply is a questionnaire, a simple pairwise questionnaire, and I'll show you an example of that. We use a questionnaire structured in a broad scale, the ones that I showed, those buckets I showed you earlier, and then the fine scale, which is the actual features. So we're getting weights on the buckets, and then we're getting the individual weights for those actual model inputs. So the AHP converts everything into a numeric value. Those then are the weights that go into the model. Complicated, not really. Here's how simple it is. We set up a survey that is given to the participants. Now, the participants of this planning process might be county commissioners, might be their staff, might be the public. So we're using a very simple questionnaire to get their assessment about what they really value, right? This is a value-based model. So what do they value? Here's an example we always show them. Dog, cat, what do you prefer? I'm a dog person, so I would strongly prefer dogs. And put that one to the right if you're a cat person, whatever. So we found that about 5% can't answer this, right? Right, Sharon? 5% of people have a really hard time answering this questionnaire because it's forcing you to make a decision. It is forcing people to make decisions. So here's the examples from the North Fork of the Crow. We had two groups that took this questionnaire separately. The policy group, which is made up of county commissioners mostly, and some leaders of their SWCDs. And their advisory group, which was mostly SWCD staff. Am I getting all this done? You just jump in whenever you feel like you need to correct me. But their staff that have detailed knowledge about, and are professionals generally about that. And what we see in this case was that there was some slight differences, and then the decision was made that we were going to use the county commissioner's response to these questionnaires as our set for setting up the weights, with the notion that they reflect the broader interest of the community. So, step 3, hit the button. Very simple, straightforward. You run it. Now we're running it on a 30 by 30 meter grid. In this case, their objective function was an additive benefit. They're looking for multiple benefits for the conservation dollar. So this is a very simple mathematical exercise. It's plus addition. It's not complicated. But this is the result that you get then. So it's ranking every 30 by 30 meter parcel from 1 to, in this case, 3 million or something like that. And then, as Mark had shown earlier, then you can do other things with it. Right? You can look at hotspots of those high priority areas and say, hey, maybe we should focus in on those. So the next slide is an output that we like to show. It's a little cleaner, consistent with good color schemes for those that do a lot of GIS work. The donation output is conservation priorities, from low to high, tan or cream colored to dark green. So the really dark green is the top 2%, 5%, whatever. You can see where those are, can't you? Do they pop out for you? You see, we got some stuff around Green Lake, a very important conservation feature on that landscape. Around Spicer, you've got large clusters of high priority areas scattered amongst the watershed. So these are priorities, conservation priorities. The last step, if I can get the clicker to work, is the synthesis step. In our case, it's a mapping exercise to generate a final priority map. Now, I've heard the other model discussions. Chuck mentioned calibration. Jim had mentioned how you calibrate the slots. We all recognize as modelers that calibration is critical, right? For you that are not modelers, your users or liars, read the book, Nate Silver's book on what was his title? Noise, the signal and the noise, why so many predictions failed and some don't. Because what a real key message that he writes in the book is that a model benefits from bringing professional understanding and experience in to revise the model output. And when you do that, you end up with better predictions. Where he talks about meteorological models and other models where the failure to do that creates models that are poor predictors. So for you that are users or liars in the group, and you're going, boy, they're just playing with some dials and changing some stuff in the models when they do calibration, well, you end up with a better product. And we all, as modelers, recognize the need to do that. Sometimes I hear people going, well, you're just playing with stuff, but really it ends up with a better product. So in our case, it's a very simple model, but it only reflects the input. So if you bring the wisdom of the people that are living and working in that watershed and have an exercise, a mapping exercise to change priorities, to elevate some areas, to lower some areas, you get a product that they're further invested into, and it captures their experiences and wisdoms in a great way. And that's how they then identify and select priority areas based on that final map. And then they can start thinking about actions. So, Mark, thanks for using that graph. This is something that we've evolved to say, okay, well, here are some of those hot spot priority areas. You might want to be thinking about conservation actions in these particular areas, using other tools, some of which have been discussed here, the PPM app that Mark mentioned, and others, about thinking what kinds of things can I be doing in these areas such that I get multiple bangs for my conservation dollars. You can look at catchments. Where are my high priority catchments? Where I might want to then use other models to say what best management practices will be effective in these areas, right? Some of them are going to be agricultural, cultivated crops. Some of them are going to be developed, urban areas. And then using the appropriate models and techniques by which you could say, what do I need to do there? We often, in addition to the pairwise comparisons that we do for weight, we often ask or use a very simple questionnaire to get at those actions. And here we had, with the North Fork Crow, we have a group of county commissioners. And isn't it a great opportunity to talk to them about what they think they should be doing there, right? So in this case, we crafted a simple one-page questionnaire to get that kind of feedback in this planning process, which the staff are very nervous about, man. I mean, don't ask that county commissioner what he really wants to do, man. I don't want to hear it. It may not be the best, but it turns out so it's a very simple questionnaire that we use, and I'm just showing you the mode results of that questionnaire, their ranks, and where they wanted to see greater effort. And the county commissioners in this watershed said their number one action that they want to see reflected in their plan was implement BMPs on eggplants, followed by restoring and protecting riparian vegetation, followed by restoring and protecting wetlands. All great things. I'm a fisheries guy. I'm looking at that. That seems to make sense to me. So now they can build on that as they write the plan. So asking people what they value, asking them what they think they should be doing, is just part of the process. And a good plan requires what? Good vision, good activities, etc. If you don't have the vision and you don't have some actions in there, it's a poor plan. It may not be as successful as a well thought out vision and action item. So that's essentially our process. So to conclude, I'm going to talk about common conservation mistakes, planning mistakes, and the shortcomings of this approach, and then the benefits. So that's where I'm going to end up with. And I got 5 minutes, and I'm going to pull that off. No problem. Great. So the 6 common mistakes in conservation planning, this is based off a paper written by Graham and others recently, is not acknowledging that conservation plans are priorities. And Chris will tell you this, is if everything's a priority, then nothing's a priority. And we've worked on rafts in some watersheds that they thought everything was a priority. Well, good luck with that, because you don't have any money to do anything, right? So we often make the mistake of not prioritizing. And this framework is designed for that only one purpose. We're only helping you think about your priorities. That's all we're doing. Second, you're trying to solve an ill-defined problem. So there's some great research on this by Dr. Pennell at the University of Western Australia, who said if your business model is random acts of conservation, you're essentially throwing half your budget away. So you better define what your problem is mathematically. Now, the North Fork of the Crow said we're going to look for multiple benefits for our conservation dollar. They defined it up front, and they're going to go look for those areas that they're going to get multiple benefits at. The third is arbitrariness is related to the second. That's the problem with getting a bunch of people in the room, right? And not having a structured approach is you get arbitrary results. You get the results of the guy that never stops talking. You get the results of you don't get the results of the quiet one that may know more about what's happening in the watershed. So structured approach is good. When we first started this, we were looking at a lot of models, value-based models, and realizing, hey, they've hidden what their true values are by either how they're weighting things within their model, and it's not obvious to the county commissioner, it's not obvious to SWCD staff. Those value judgments are obscured within the details of their model, and that's not good. And then the last two, which we don't address within our framework, is not prioritizing actions, although we help, and then not acknowledging risk of failure. So those are the common mistakes. The shortcomings specifically with our framework, the way that we've employed it, are the following. It's a value-based model. I've heard this, well, that's not good. You're just using the values of the people in the room. Okay, all right, we acknowledge that. It does require commitment from participants. We've found that if the group is not committed to a planning process, you're not going to get a good result. And, so the model isn't going to save you. The approach won't save you. It doesn't provide any answers either, by the way. It's up to you to get the answers. It's just the framework. Doesn't prioritize action, doesn't prioritize knowledge risk of failure. So the benefits are, it's a value-based model. Hey, it's incorporating the value of the community, the value of the people that are writing the plans. We think that's appropriate. It produces priority areas so that you can move to your next stage about whether you're using PTM, app, or other tools to say, okay, these are my priority areas. What do I need to do there, right? The goals and the processes are clearly defined. It's quantitative, yet transparent. The people are building the model as they go. So they know exactly what's in it. And then with the fourth step, that synthesis step, it captures the knowledge and wisdom of the group that's involved with it. And it's pretty flexible. It depends on the group. We can move as fast as the group wants to move, and when we come in, or as slow as they want to move, and that's really frustrating too, but that's another issue. So in summary, there's many benefits of a formal qualitative planning framework. I don't care if you use Zonation. In fact, Chris and I are only two people. We're not going to get a lot of extra money for this, right, team? But I will say, if you're doing a plan, what is your structured way of coming out with an objective plan process? Think about that. We think this approach facilitates a very efficient, it's organized process to get spatial priorities. And that's all we're doing, spatial priorities. But the reason we're involved again is the priorities for clean water can be integrated with other priorities, other multiple benefits. Habitat. Did I beat that, Henry? Henry's still here. 4? I got him, because he only said 3. So, that's our summary. That's my pitch. Those are the key messages. Are there any questions?